Hello, everyone. Good evening, everyone. Can someone confirm that you can hear me and you can see my screen?
We can both see and hear you and see your screen.
Thank you so much. Who is this? Krista. Thank you so much. Fantastic. Are there any questions? Anything? Okay, I posted the announcement for test 2. Please check out the announcement. Test 2 is next week. Okay. Today we are going to do session 9, ARIMA methodology. Recall last class, we did multiple regression. So in session 8, we did multiple regression where you have one dependent variable y, and you have multiple x. We call x1, x2, x3, etc. So those are multiple independent variables. That was session 8. So this session is about, we just dealing with y, no dependent variable. So in session 9, we just have y, no x. Okay, and I'm going to give you a lot of examples. Through these examples, I will explain the ARIMA methodology, the concept, the techniques, the procedures, and finally, how to realize the technology, how to realize those methodologies through SPSS. Okay. You are welcome to ask questions throughout the lecture. You can type in your question in chat area. I try to monitor the chart, or you can directly speak up. Okay. All right, so let's dive into the example. Okay, this example, the data file I posted on Excel. It is on chapter 9, CH9. Go to D2L, download CH9. Okay, so this is the data file about a company's auto readings. Okay, it is a time series data, time series data. Okay, total we have 75 cases, 75 cases. So what are we going to do with this data? So we are asked 2 tasks. One is to fit AR2 model. This is task 1. Task 2, forecast when time period equal to 76. Remember the original data sample size 75. Okay, you are asked to forecast for t equal to 76. Okay, so first of all, I will explain the keyword AR. Okay, AR represent auto regression. Okay, AR represent auto regression. What it does, remember in this chapter, we do not have X. The only thing we have is Y. Okay, so for example, this is the only thing we have, no X. All these values are Y. Okay, so the first one is Y1. Okay, this number is Y1, and the next number is Y2. Okay, so generally speaking, we say we have YT. Okay, so y1, y2, y3, generally speaking, yt. Now, what is the number before yt? Can anyone answer this question? What is the notation that represent the number before yt?
Yt minus 1.
Perfect. Thank you so much for your participation. And what is the number before yt minus 1?
Yt minus 2.
Fantastic. So all these numbers are y. We don't have x. Okay. So for AR2 model, so autocorrelation, autoregression, we want to set up a model, okay, so that yt has something to do with y. Sometimes I do not distinguish small letter or capital letter. Okay, so that's consistent with the textbook notation, capital letter Y. So I want to relate yt with yt minus 1 and yt minus 2. So this model I call AR2. So related, autocorrelation. Okay, why it is 2? Because yt relates to 2 times lag. Okay, so this is a AR2. Because I want to relate to this one, I may have some constants. For example, I may have a constant we call phi 0. Okay, and the coefficient for yt minus 1, I call that is phi 1. And then the coefficient for yt minus 2, I call that is phi 2. And now this equation, and then plus error term, so epsilon t. So this equation is AR2 model. Okay, means a variable yt related to the number before it and the 2 number before it. So this is right now yt. And this one is AR2 model. In this equation, we only see y, we do not see x. But this one looks like the one we did last week. Remember last week, if you have 2 independent variables, you may have, for example, b1, x1, b2, x2. Maybe there's a constant here, and maybe there are some error. You may see this format. And if you compare these 2 formats, they are similar, except we don't have x here. But you can relate the first equation with the second equation. The format similar. Actually, they are exactly the same format. Okay, just use different notation. Okay, so the task asks you to fit AR2 model. It is asked you to find out what is phi 0, what is phi 1, what is phi 2. If you can find those 3 numbers, you can write down an equation between yt minus 1, yt minus 2. That equation is the AR2 model. Any questions about what is AR2 model? And once you have this AR2 model, you can make a forecast. Okay, so that is the brief introduction about what is AR2 model. Now let's go back to this question. Use SPSS. How do I get this AR2 model? Okay. So you need to enter data into SPSS. If you have data in Excel, you just need to copy and paste it to SPSS. Okay. So I already have that number, so I'm going to open that number. That is example 1, 91. Do I have that number 91? It is actually the same as example 9.1, 9.2, 9.3. We all use the same data. So I may just open this data here. Okay, so I'm going to delete those. So this is the data identical to Excel data. We have 75 cases. Okay, we have 75 cases. So how do I fit AR2 model? You do this. You go analyze, forecasting, create traditionals, analyze, forecasting, create traditional models. So keep in mind what we are going to do here. We are trying to find 3 numbers, phi 0, phi 1, phi 2. Okay, those are the coefficients. How do we find those 3 numbers? We use SPSS to find those 3 numbers. To click here, because this is the time series data, you have this dialog box, ask you to create date and time. In this example, we don't care about it if it is monthly data or weekly data or yearly data, we don't mind. So I'm just going to omit that. Okay. And now you have this box. Dependent variable, it is just this reading, this number, auto rate. We do not have independent variable. And we are going to use ARIMA method. So we start step by step. We take baby step first. By the way, AR is part of ARIMA. ARIMA is very general. So we start with simple step. We start with AR. Okay. So then you click criteria. After that, you are asked to so there are 3 numbers here, P, D, Q. Okay, P is the auto-aggressive. So in our example here, where is my Excel file? If you want to relate YT with YT minus 1, YT minus 2, in this case, P equal to 2. Okay, you relate YT to the previous 2 periods. Okay, leg 2, that is P. Okay, because we just need P here, so this AR2, it is the same as ARIMA 200. It is the same thing. Okay, we start with the simple one, AR first. Then we'll talk about MA. Then we'll talk this I represent integrated. So auto regression integrated with moving average. By the way, MA stands for moving average. So for now, you just think AR is part of ARIMA family. Okay, AR2 is equal to ARIMA 200. So this is P, this is Q, or this is a P, D, Q. Okay, P equal to 2, D 0, Q 0. We'll see D equal to other numbers, Q equal to other numbers later. But first, we're dealing with the simple case. Okay, all right. So go back to SPSS. Okay, so auto regression typing number 2. Okay. Suppose this data is non-seasonal. If it is seasonal, we have other example. Okay, we are going to dealing with later on. So then I click continue. Okay. Remember our objective here, try to build a model. What is the model looks like? That model is this one. This is the model we are looking for. This is the model we try to build. Okay. So that is specify this one here. And then we can go over other options in this dialog box. For example, we want to use R square. Okay. You can display forecast. Okay, but for now, we forget forecast. We just set up model first. We can do multiple tasks at the same time. Maybe I change my mind. I want to display the forecast. Okay. And for the plot, I want to select residue autocorrelation, residue partial autocorrelation. Okay. And then I want to select R square as a way to comparing models. Usually we don't select anything from output filter. And from the save, I want to see the predicted values. Okay. And under the options, I want to see the first forecast value. Remember, we want to see what is the forecast for time period 76. The given data have 75 sample size, case number. We want to predict 76. Okay, so all set up. We can just click OK button. And this is our output. This is the model summary, this table. Okay. The import, it is telling you what is the root mean SE. Okay. Check out chapter 3 for those measurements. Okay. And then we have model statistics. Model statistics, but where is my model? Where is the 3 number I found out? I will tell you later, okay? And this is the autocorrelation for residue. You see they are between the upper limit and a lower limit. So those residues between upper limit and lower limit means the model is pretty good. Okay. So, but where is my model? How do I write down the model? You can't. The reason you cannot identify the model is because you missed a step. Which step you missed? Yeah, but you do get the forecast here. See, those are the forecast numbers. And you even get the forecast for time period 76. You get this because remember we click the save button. Okay, so those are the forecasts for all the numbers, not only the 76, not only the 76, but forecast for all other numbers. Okay, so now which step I missed? Why I don't see my model? Because you didn't click the parameter selection. Where is the parameter? So when you go to statistics here, we didn't click parameter estimate. You have to click parameter estimate to get the three numbers, phi 0, phi 1, phi 2. Remember, we need three numbers to write down AR2 model. Okay, so once you check out this, you click OK. And you got those three numbers here. So phi 0, that is the constant, 75. Okay, phi 1, that is time lag 1, negative 0.528, phi 2, 0.005. We have that three number, we can write down the equation. Okay, so from this procedure, those are the computer steps. Okay, after these steps, if I make this bigger, yeah, so this number is my phi 0. This 0.558 is my phi 1, negative 0.347, that is my phi 2. Okay, and once you have this, oh, this is not this one, this is a MA. I should found the other one. This is example, next example. So, okay, I should copy this screen here. So this is the AR2 model. Okay, AR2 model. I'm going to copy and paste it beside. I'm going to paste it here. Okay, so see, this is our AR. So this is phi 0, phi 1, phi 2. So our model is yt equal to phi 0 plus yt minus 1. Maybe I will keep consistent. Yt minus 2 plus epsilon t. Epsilon t is the random error. Okay, and then plug in the number from SPSS 75.3 and plus this should be half phi. Coefficient phi 1 yt minus 1 and then plus phi 2 times yt minus 2. Okay, so this, because phi 1 is negative, so it becomes negative 0.528 yt minus 1 plus 0.05 and then yt minus 2. Okay, plus epsilon t. This is our model. Okay, and based on this model, you can forecast for t equal to 78. The result is 77.2. Okay, so we finished example 1. Example 1 asked us to create AR2 model. The answer is this is AR2 model. This is AR2 model. And example 9.1 asks you to forecast 76 when time equal to 76. The answer is 77.2. Okay. Any questions? Okay.
Professor?
Yes.
I have a question here. In the chart, where can I find the error number?
Are you talking about this epsilon t?
Yes.
This error term, remember we do the linear regression. We say y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon. Remember, this is familiar.
Yes.
This is the model for population. When you're dealing with the sample data, this equation becomes y equal to b0 plus b1x plus b2 x2. So the error term is 0. When you do the forecast, this error term becomes 0. So if you forecast for y76 equal to 75.327 minus 0.528 times yt minus 1 becomes t75. So what is t75? You have to take a look at t75 is 72. Okay, so because this is Excel, row 1 is the heading, row 1 is heading. So y75 is 72. Okay, and you plug in, where's my notation here? So times 72 plus 0.05 times t minus 1, what is t minus 1? 99. Thank you. Thank you, Benny. Try to switch more. 99. This error term is 0. Okay, and this number you should get 77.2.
Thank you.
Okay, thank you for your question. That's great. Any other questions? Okay. By the way, today's lesson is very important, ARIMA model. If you add this methodology to your resume, it will stand out. Okay. So this ARIMA model is very demanding, and but usually the explanation from the textbook, for example, our textbook wouldn't give you the procedure for SPSS. It just gave you the output from Minitab. It didn't tell you how to get the procedure. This is the gap I'm filling in. I showed you the procedure. Okay. So please ask questions. Okay, this is the chance to ask questions. Okay, so we finished the example 1. We fit AR2 model and we forecasted for t equal to 76. Okay. Now example 2, we use the same data, but this time we are going to fit MA2 model. MA stands for moving average. Moving average. So what does the M2 model looks like? M2 model looks like. So this time, remember, okay, I'll use this one. Use the same data set, okay? So I'm going to delete one, just keep one forecast. Okay, remember this 75.3 is the forecast for 60. And this 83.5 is the forecast for 81. If you know the forecast, can you calculate the error, ERROR? Can you calculate the error? Anyone? This is the observed value. This is the forecast value. What is the error?
You just subtract the two.
Wow, thank you. You just subtract the two. How do I subtract? If you use Excel, easy job. But when you use SPSS, you have to do transform, compute variable. Now I'm going to compute ERROR error term. Okay, so this error term is original data, subtract predicted data. Okay, then you click OK button. So go back to SPSS. See, this is the error term. So if you use 60 minus 75, you get negative 15. 81 minus 83, you got negative 2.46, etc. Okay, so I'm going to copy this because I need to make a notation. I'm going to copy this. Where should I paste? Maybe paste below it. This is here. So what I try to do, I try to explain MA2 model, okay? To explain that, we need to know these are the error terms. So this is E1, E2, E3, E4, etc. Okay, so generally speaking, I will use ET. Okay, I will use ET. So if I use ET, what is the number before ET? One time lag. What is the number before ET? How do I express that number? Matthew, thank you. It is ET minus 1. And then what is the error term before ET minus 1? Anyone?
ET minus 2.
Thank you so much. And thank you, Matthew, for your answer from the chart. So ET minus 2, perfect. Okay. Okay, so what is the remember MA represent move-in average. Move-in average. So those are the original number. If you have original number, can you calculate the mean? Of course, you can calculate the mean. We use mu represent the mean of the population data, original number. So you understand what is this mu, the average of original data. Okay. Okay. So we are saying in order to fork the YT, it is just the mean of original data. Okay. Rearrange I need space. So mu represents the mean. So I am going to write down equation between YT and mu. When I write down the equation for population, usually I use, this is the E for sample, small e for sample. For population, epsilon. So epsilon is the same as E, except epsilon refer to population, this E refer to sample. They have the same meaning to represent the difference between observed and predict. Okay, so the model uses epsilon T minus 1. And then I still need more space. So mu and then epsilon T minus 1, epsilon T minus 2. I want to set up relationship between YT, mu, and then I have a coefficient W1, omega 1, not W. Omega 1 times epsilon T minus 1 minus omega 2 times epsilon T minus 2. And then there is an error term. I call that error term is a epsilon T. This equation is MA2 model. So the relationship between YT, epsilon T minus 1, epsilon T minus 2, this relationship called MA2 model. Any questions? Just going to grab a cup of tea. Any questions? So to fit MA2 model, we just need to find 3 numbers, mu, omega 1, omega 2, and epsilon T, usually it is 0. Once we found those 3 numbers, we can set up an equation. Once we have an equation, we can make a prediction. Okay, any questions? So this is our example 9.2. Okay. So 9.2 will use the same data for 9.1, but use MA2 model. Still ask you to forecast when t equal to 76. Okay, so now let's use SPSS to do it. Okay, so I'm going to delete those numbers I created. So this is new example, example 9.2, fit MA2 model. Okay, go to analyze, forecast, create traditional models. Just click OK. Click the variables, reset. ARIMA rate, this is our Y dependent variable. From the method, we use ARIMA. Criteria, this time, we are going to use moving average, MA2. Moving average, so Q equal to 2. Okay, click OK button. And then go to statistics. Remember, if you want to set up model, you need a parameter estimate. So don't forget this. And we also need to make a prediction forecast. Okay. Plot, we want residue.
Sorry, Professor, do you need to have the parameters checked or not? It looks like it's unchecked.
Thank you so much. Yeah, I should check out parameter. Okay, thank you, Krista. Okay, now the plot looks fine. We don't do anything about output filter. Click save button. The presented result will be saved to here, remember? And then options, we want to forecast 76, forecast 76, that's it. And then when you click OK, you get this model. Do I have the parameter? I still don't have the parameter. But I do have this here.
Just can you turn off your mic, please?
Oh my God, I'm so sorry.
It's all good.
Yes, if you don't have question, you do not need to speak. Please turn off your mic. Thank you. All right. So we have the output here. It's the same output here. Oops. I don't want to undo it. Actually, I don't see the parameter here. Maybe I remember I clicked it, but sometimes it didn't register. So I'm double check. So forecast, create traditional model, and then I need to double check. See the parameter estimate. I should click it, okay? And then click OK button. So now I have these 3 parameters, okay? I have constant, this is my mu 75. Then I have omega 1, 0.558. I have omega 2, negative 0.347. Okay, so those I have the model. Okay, so I'm going to go back to my OneNote. Those are the computer procedure. This is my result. So based on this result, this is my mu. And this is my omega 1, omega 2. So the model would become YT equal to mu plus mu minus omega 1, epsilon t minus 1 minus omega 2 epsilon t minus 2, and then plus an error term epsilon t. So this is the model. This is the model. Okay, and you can make a forecast based on this model. So this model is my MA2 model. Based on this model, the forecast for 76 is 80.5. The forecast for 76.
Professor, I have
Yes.
a question here. Why is minus omega 1 not plus? You see,
Oh, okay, yeah, good question, Benny. This is the way when statisticians who invented ARIMA method, this is the way they set up. Okay, so they use minus W1 minus W2 instead of plus W1 plus W2.
okay, thank you.
You're welcome. All right, so this is an example. Example 2. Any other questions? Okay.
Yeah.
Yes.
Hi, Professor. So SPSS, we have to use it for the test, right? We can't just use Excel.
Excel cannot do a ARIMA method. You have to use SPSS.
Right. Okay. But everything else you can use Excel, right?
Sorry.
Yeah. So you just need SPSS for the ARIMA, right?
Correct. Or you can use R or Minitab or but not Excel. Excel has no functionality to do ARIMA.
Okay. Thank you.
Okay, you can use Minitab, you can use SAS, you can use R, you can use SPSS. Okay. All right. Any other questions? So next example, pretty long. We are going to consider a lot of the next example. So shall I suggest we take a 10 minutes break? After break, we'll start with 9.3, 9.3, okay? So shall we come back at 7:25, okay? Then we start with 9.3. So I'm going to stop recording. And when we come back, I will quit recording again. So where is this box? I can move this.